Okay, so today we're going to be looking at writing and solving proportions. We're going to talk a lot about ratios, looking at this. And so first of all, I want to talk first about what a ratio is. Remember, a ratio is just a comparison of two quantities, and you could really be comparing anything that you wanted. And so the first one is asking, it wants us to write a ratio of soccer balls to water bottles. So count, how many soccer balls do we have? We have one. I'm going to make this a little bit bigger so I can write. And then we have 2 water bottles. So one way we could write the ratio is we could say 1 to 2. Sometimes you also see it with the little colon. So 1 soccer ball to 2 water bottles. You can also see it as a fraction, which is primarily how we're going to be looking at our ratio. So all of those are different ways to write that ratio for soccer ball to water bottles. Okay, let's look at the next one. We have cones to things you wear. Okay, so how many cones do we have? It looks like we have 3 cones. And if we count everything we can wear, our mittens and our cleats, that would be 3 to 6. Again, we could write that with a colon. But I hope you're thinking to yourselves, hey, Miss Adams, that could also be reduced. So again, you could still write it as a fraction, or we could also write it reduced as 1/2 or 1 to 2. All of those ratios mean the exact same thing. Okay, and then the last one was cleats to total equipment. So it's really important to we're paying attention to what it's asking. So we have 3 cleats, and if we count the total, which to me, that means total would include all of the cleats as well. So that would be 3 to 12. And again, writing it in all the different ways that we could. And then I hope you're seeing also that 3/12 or 3 to 12 could be reduced to 1/4. And so all of those ratios we could also write as 1 to 4. Now we've already been working with proportions in this unit as we found unit rates, but I don't know that we really talked about what the definition of a proportion is. A proportion shows that 2 ratios, 2 fractions, 2 ratios are equivalent. And we put it in the form, they are equivalent. We could also say they are proportional in the form of an equation. Now we've already talked about that we can do some cross multiplying by setting up set up an equation and solve it. I'm also going to show you some scaling. It's just that scaling doesn't always work. I know last year you may have talked about cross multiply and divide by the lonely guy. Do you remember hearing that? The lonely guy in this case is 3. We've already been doing a lot of this. To solve this, see, we're dividing by the lonely guy of 3, and we get x equals 16. This shouldn't be anything new, really, at this point. That is setting up the equation and solving, cross-multiplying, setting up our equation of 3x plus equals 48, and dividing by the lonely guy 3. Now, scaling means here we have 3 and we have 24. Now, can you think of a number 3 times what might give you 24? I hope you're thinking 3 times 8. And so when it's very clear like that, then you can just multiply the top by 8 as well. 2 times 8 means that x is 16, which is what we just found out when we cross-multiplied, right? So if it's very obvious what we're multiplying by, then you can do that. But it doesn't always work that way. It's not always a clear number. Now, we worked with unit rate, setting up our proportions, And we talked about, first of all, that writing the words was really important. We're still trying to skip that step, but as we write full proportions and we're comparing other things and we're not necessarily finding the unit rate, it's really important that we know what we're putting on top and what we're putting on bottom. If you read this problem, we are talking about pilots and aircrafts. And so you do have some choice in this matter, which is a little bit different than unit rate. In this case, I'm going to go ahead and I'm going to put pilots on top and I'm going to put aircrafts on bottom. But what I want to tell you is you could do it the other way. You could put aircrafts on top and pilots on bottom. You have a choice here. It doesn't matter, but it's important that you know what you're putting where. Now, let's go back to our first way that we set it up, pilots over aircraft. So when I write my two ratios, we know 40 pilots for every 15 aircrafts. And so I'm going to put 40 over 15. And then it says if they employ 240 pilots, so that would go on top, how many aircrafts does first class own? So it's really important we know where that X is going to go. I want to show you, same thing, if we did it the other way on the bottom, the only thing that would be different is that our ratios would be flipped. We would still get the same result as long as we put the numbers in the correct place. Okay, so now let's look at solving this. Now, first off, I'm looking at this and I'm saying, oh geez, there's a lot of numbers. I do see that we could possibly scale, but I also want to remind you that you could do some simplifying or reducing of your numbers. For example, I see that 40 and 15 can both be divided by 5. Now, there are lots of different ways that you can simplify with proportions, but for now, until we get really comfortable with it, I want us to stay with just simplifying within the same ratio. Okay? So now we're going to go ahead and cross multiply. I have 5x equals 3 times 240. And you can take my, whoops, I messed up. This should be 8. Whoops, I'm glad I caught that. That should be 8 because I divided by 5. 40 divided by 5 is 8. So sorry, glad I caught that. And take my word that 3 times 240 is 720. And so now all we have to do is divide by the lonely guy, which is 8. Okay, I'm going to move down here to the bottom so we can talk about this work. We have 720 divided by 8. 8 goes into 72 9 times, and then it won't go into 0. So 0 times. And so that means for this that we have, it says how many aircrafts? We have 90 aircrafts. Okay, lots of different ways that we could approach this and solve this. I just wanted you to see the 2 different ways that we could set this up and remind you of your cross multiplying and the simplifying that you can do. Okay, let's look at the next one. We have the ratio of creamy to crunchy peanut butter. So those are the 2 things that we're comparing. Now, since this is a ratio and it's saying creamy to crunchy, I know I would probably get confused if I switched this around and put crunchy on top, but it's not wrong if you do, as long as you are keeping the right numbers together. And so it says the ratio of creamy to crunchy on a grocery store shelf is 5 to 3. And so that means 5 creamy to 3 crunchy. Okay. It says there are 18 jars of crunchy. So where is the 18 going to go? I hope you thought, hey, it's going to go on the bottom, Miss Adams. And then that means our X is on top. Now I don't see anything here that I could simplify, but let's try some scaling here. Does 3 go into 18 evenly? Can I say 3 times what is 18? I sure can. I can say 3 times 6. Or I could cross multiply like we did on the first one. 5 times 6 is 30. Now, let's make sure that we've answered our question. And I'm noticing here it says, what is the total number of jars of peanut butter? Well, 30 is just the amount of creamy peanut butter. But I have creamy and I had 18 crunchy. So when it's asking for the total, we're going to have to do some adding. So 30 plus 18 is 48. And so there are 48 jars of peanut butter. And so as you work through your scavenger hunt in just a minute, really pay attention to what is it asking you to find.